All right, hello, let's finish with this review today. Remember, if you have a perfect square minus a perfect square, you can split it into these two guys. So I know that I really have x minus 1 to what? The third power. And I have x plus 1 really to the fourth power. And then I have that x squared plus 1. Okay, so now here it says find all the zeros. It doesn't just say, rational or real or anything like that. It says find all. Okay, so this is positive 1, right? Would be one of our roots or answers. Okay, and let's see, positive 1 has a multiplicity of what? 3. Here, a negative 1, and that has a multiplicity of what? 4. And whatever causes 0 here is okay. So we're like, all right. As far as what's going on here, we have what? 2, 3, 4, 5, 6, 7, 8, 9 is the degree of the whole thing if I multiply it out. So far I have 7. And I know this is going to give me 2 more answers. It is not factorable. So it is not going to give me a radical or, this is imaginary here. Okay. You could do quadratic formula, but if I treat it as a squaring function and set it equals 0, square both sides, remember you should get 2 answers. You get plus or minus I. Okay. So you get a positive I and a negative I. Okay. So those are your 9 answers. This one, multiplicity 3, this one, multiplicity 4, and then those 2, and you should be good. And I just want to double check. I have x minus 1, yep, to the third power, and then x plus 1 to the fourth. Yeah, so we should be good. All right, I'm going to look at the next one here. I'm going to pause for a second and we'll look at the work for that one. Okay, so let's look at this one. I did the last shall be first. Okay, so plus or minus 4 and 1 and what? Plus or minus 2 are possibilities, and then divided by plus or minus 1. But this one says, or plus or minus 1, plus or minus 2. This one says I can use a calculator or say Desmos to help me. So what I did is I graphed this on Desmos, and I noticed that it has an x-intercept of that, and that. Okay, so when I graph it, I can see those x-intercepts. All right, so I'm going to pause. I'm going to show you the graph quick. Okay, so on this one, I want you to find all the roots. So you want to look for the pretty ones. So there's a negative 2. That's nice. That one is not pretty, but it's not imaginary. It's a real one. It's going to be a radical. It's going to be the square root of some number. This one is going to be, ooh, pretty, a half, because it's rational. That's nice. 2. And then again, another non-pretty one, which is again going to be a radical. Okay. So the rational 0 theorem definitely would give you this one, and this one. But remember, the rational 0 theorem, all the factors of the last over all the factors of the first divided, never gives you radicals. That's the downside to that one. So we're going to cheat and use synthetic divisions with the pretty ones. So we're going to do this pretty one right there. We're going to skip the ugly one. We're going to do this pretty one here, this pretty one here, skip here. And then when we're done, we should be able to use a quadratic formula or factor, or do some, or not factor, square root both sides or something to get the 2 radicals. All right, I'm going to pause and go back to my paper. Okay, so what I did, I started with 2. Again, synthetic division, I had to put a 0 here because I'm missing an x. Synthetic division, bring down, multiply, add, multiply, add, multiply, add, multiply, add. And you should get a remainder of 0 because you know it is a 0, right? This is an x-intercept. Then I do a half. All right, bring down, multiply, add, I get 0, which it should, otherwise I messed up. And I do my negative 2, same thing. And remember, you work off the leftovers because your goal is to bring it down to something that you can either do square rooting on both sides or do the quadratic formula, or maybe factor if you want to, if it's something where you're going to get all pretty ones. All right, so negative 2, multiply, bring down, and then multiply, add. Okay, at this point, these are the only 3 pretty zeros, right? The other 2, are square roots. And this is a trinomial, so it's not like you can square root both sides. You have 3 things. So I'm going to have to use a quadratic formula. So come over here, opposite of b, plus or minus b squared is always positive 16 minus 4ac all over 2a. Again, always just type that in a calculator, let it do order of op, which is 32. 16 has a square root, 2 doesn't. So you take the 4 out from that, and the 2 is stuck. And then because 4 goes into both of those, I can divide by 4, and I get 1 plus or minus square root of 2. So I want to find all my zeros, okay? So there's the 3 pretty ones, and then these are the 2 radicals. And if you type those in a calculator, they are the decimal approximations that Decimals gives you. But I can find all 5. The graph can give me a head start so that I can get to something that I can do the quadratic formula on to find all of the radicals and all of the pretty x-intercepts total. All right, I'm going to pause and we'll go to the next problem. Okay, so for those of you that are in my online class, these are going to be extra credit questions. So one of them is going to deal with upper and lower bounds, okay? So with synthetic division, you always have to go back to the original. You're not trying to factor it down so that you can find all the zeros. This is just, you are trying different things to see if your screen is big enough. Because what could happen is you might be like, oh, I found all the zeros, yay. And there might be one out here and your screen is only that big, okay? And maybe there's one over here and you don't see them. So you think there's just one x-intercept, but there's actually 3. And you might be doing the rational zero theorem, the last over the first, but the problem is that doesn't give you radicals. So this could be the square root of, who knows, 37 out here. And you think you have all the zeros, the real zeros, but you don't, okay? So this is where you can do synthetic division. You have to start with the original all the time. So I took the original and I tried 10. I took the original, I tried 20. Took the original and I tried 30. And notice when I do synthetic division with 30, I get all positive or 0 answers. That means you have an upper bound. So that means if your graph paper goes out to positive 30 on the x-axis, any radicals, any pretty ones, you will for sure have them all, okay? If you go to 20, no, okay? You don't for sure have them all. But if you go to 30, you for sure have them all. And I chose to go by tens because this is such a huge number, you know, 4,000's big. So I don't want to go 1, 2, 3, 4, 5, 6, 7. All right. Same thing on lower bounds. I'm going to go by tens, negative 10, negative 20, negative 30. You always have to go back to the beginning. And what you're doing is you take the beginning, do synthetic division. Do the beginning, do synthetic division. And what you're looking for on the lower bound is alternating. So again, if you have negative 20, there could be a lurking one out here. But notice when I do negative 30, it goes positive, negative, positive, negative, positive. They alternate, right? Positive, negative. So that means a negative 30. If I graph this function, I am for sure going to see all my x-intercepts, even if they're radicals, okay? That will be extra credit on our test, okay, in our online pre-calc test. Okay, another thing is one of our labs was on the bisector method, all right? This is going to be an extra credit option as well on our test if you're in my class. And so on this one, remember, we have the intermediate value theorem. Now that you should know that if you sub in input and get a positive output and you shove in and sub in a different input, you get a negative, that you know that, you know, here's negative 4 and 5. If you go negative 4 is a negative outcome and negative 5 is positive out here. Okay, and again, not to scale, but it has to cross somewhere in the middle, right? Or someone between, maybe not in the middle. But if you have a negative output and a positive output, somewhere there has to be a 0 in the middle. Okay, that you should know, not for extra credit. But for extra credit, we would do the bisector method where you have negative 4, negative 5. And remember, you cut it in half and you check it. This output is positive. So you can't go between a positive and a positive, right? Like, you know what I mean? So negative 5 also gives you positive output, right? So between a positive and a positive, that would be like, oh, I'm right here and I have another positive. Like it can't cross. So this is a no, right? This is a hard no. So then you're over here. So then you check 4.25 and you decide, oh, my output is positive again. Well, positive, positive. Again, that is a hard no. And then you go halfway between there. And again, you can average to get the half, right? 4.125 negative. And you sub it in and gosh darn it, you get a positive. So what's happening is you're getting all these, you know, you keep cutting in half, but you're getting all these positive outputs. So maybe these are all going to be positive outputs, right? So then you're like, oh, you know, so you're slowly working your way this way because you're like, I tried that, tried that, tried that, tried that. I'm just slicing it in and they're all no's, right? So this is a no, okay? Finally, you try this and you get, which again, just average, take that, divide by 2, add and divide by 2. You try this and you get a negative output. So now you know that you're somewhere between there and there, right? So if I'm somewhere between there and there, you know, I could average those again if I wanted to, but that's kind of where I need to be. All right. So again, that will be extra credit on our exam if you're in my class. All right. I'm going to pause and we're going to move on. Okay, so if it has degree 4, that means it has 4 zeros. And remember, imaginary always come with conjugates. So 2i would come with a negative. 2i, negative 8 plus I would just change the inside number to negative 8, but you'd make this negative I. So that's conjugate, conjugate, and I have 4. All right, the next one, going with that same problem, says, what was the original function? Okay, so remember how when you do zeros, it's always opposite. So like, if I have, say, a positive 2i, I do a negative 2i. If I have a negative 2i, I do a positive. So if you have a binomial, you have to subtract all of it. So what's going to happen is this guy's going to become positive, that's going to become positive. And on this one, this is going to become positive, that's going to become negative because you have to distribute it. So you can see that down here. These are all opposites. Now, you have to multiply this puppy out. You can use a box, whatever you want. Here you might do first, outside, inside, last, and get that. Here, I did the box over here. And remember, all the I should cancel, and then I squared is 1. Okay, so that's where I got 64 plus 1 is 65. So again, the I should go away when you do that. And then this one I just distributed. Once I got rid of the I's, I took the x squared times everything, the 4 times everything, and added. But you could do a box. You could do a 3 by 2 box on that if you wanted to, if you like the box method. Okay, but again, here I did first, outside, inside, cancel. Last is a negative 4i squared. Remember, I squared is a negative 1. That's how I got the plus 4. Here, when I do the box, I have ix, negative ix, they cancel. I have 8i, negative 8i, they cancel. And a negative I squared would be a negative negative 1, which turns it into a positive 1. So then when I collect like terms, that's how I get this. But then you still have to multiply those out. Okay. All right. That's your final answer. And you could graph this, but the problem is you should have no real zeros because they're all imaginary. So it doesn't help you too much to graph. All right, I'm going to look at the last one. Give me just a second. Okay, so let's talk about this one. Say we have a piece of cardboard or whatever. I'm going to cut out X by X in every corner. So it could be 1 inch by 1 inch, half an inch by half an inch, but they're all going to be the same. And then I'm going to fold it. Okay, so I'm going to pause this, actually cut them out and kind of fold it so you can see what's going on here. Okay, I cut my corners out, and then when I fold it, you can see I'm going to get a 3-dimensional box, okay? And we're going to fill it, so with volume, like fill it with sand. All right, so let's think about the original. Okay, the long side was 20. Well, notice I cut an X from distance from that side and an X distance from that side. So the new length is going to be 20 minus what? 2X, okay, when I fold those up, because I'm going to subtract 2X distance-wise. This side was, what was this one? 15. The short side was 15. But again, the same issue. I subtracted an X distance here and here. So that would be 15 minus 2X. Okay. So that's that distance. Okay. So that's my length and width. Now notice how tall is it? Well, you can see when I fold it up, whatever X is the height. And so to find volume, you need length, width, and height. Well, you know all those. Okay. So you know the length, the width, and the height. Okay. So in algebra, you use formulas, you know, length, width, height for the volume. I sub in my variables, distance, length, and width, and my height. And what I'm going to do is I want to know when is it going to have 300 cubic feet, okay? So I am looking for when does it hit that. So I'm going to graph this guy as one function, the 300 as the other, and see where they cross, okay? And I'm going to pause and put that into decimals so we can see that. Now, this is where domain comes in. Do you notice if, say, X is 10, this would be 0, and then this would actually be negative. So even if X is 7.5, that would cut your 15 and you'd have no volume. So your domain, I mean, you can't even really have 7.5, okay? So I'm going to go to my graph quick. And so like over here, that doesn't make sense, okay? Let's look here. 4.1. Let's see, that gives that answer. So let's see, I'm not even on there. Let me get on there. There we go. 4.5 looks like that will give me 300 for the volume. And then over here, looks like about 1.5 will give 1.45 will give me 300 as well. Okay. So there's 2 answers that make sense. All right. As far as for, if you cut that out, it's going to maximize your volume, right? Over here, this one, you can't have 11.8, right? You'd have you cut more than exists on your shape. So that is not going to work. Okay. So the two answers I have are right here. Those